to the stage Bob Baddeley. Are you guys ready for Bob Baddeley?
I'm always ready for Bob Baddeley!
Baddeley is a computer science engineer. He also works with plastics and consumer products. He's made some cool shit, including a Bluetooth-enabled outhouse, which we might ask him about later. He's a member of Sector 67, he's pretty cool, and he's going to talk to you guys about plastics. Join me in welcoming Bob Baddeley to the stage.
Woo! 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 Portable scores.
Hey, is that a portable scoreboard?
How can I get one?
Hi everybody,
Hi, Bob.
I'm Bob, and I hope to get this done in 19 minutes and 46 seconds. So, I'm going to talk to you about how your stuff is made. Hopefully, by the end of this talk, you will be able to mansplain everything that you hold. So, my degree is in computer engineering, but I work for a lot of hardware startups building internet-connected devices. And that means that I have to dip my fingers into all aspects of manufacturing products, and that means that I've done a lot of work with plastics lately. So one of the products that I've worked on is Portable Scores, which is the scoreboard that's keeping time right now. I designed and built that. Pretty cool, huh? So, the beginning. Starts with dinosaurs. They were stoppable. They were stopped. And now we do a lot of chemistry and magic to turn dinosaurs into dinosaur pellets. So this is the raw material that pretty much all plastics are start as. These are just plastic pellets, and there are a variety of different kinds of plastics. But we can add things to them, like colorants and fire retardants and a whole bunch of other things to make them different. And we can recycle plastics so that we can clean them up and turn them into flakes. So pretty much everything starts like this. Now there are two different kinds of plastic categories. There are the thermosets and the thermoplastics. The thermosets mean it's pretty much one and done. You can't do anything with it. They're not recyclable afterwards. So once it's set, it's set. Thermoplastic means that it's recyclable and we can heat it up and it will get soft, and then once you cool it down it gets hard again, and then you can heat it up and it'll get soft and you can reuse it. So among the thermoplastics we've got PET or PETE, P-E-T-E, they're actually the same thing, and that's polyethylene terephthalate. There's PVC or polyvinyl chloride. There's HDPE, high density polyethylene, and ABS, acrylonitrile butadiene styrene.
Woo!
Yes, it takes a talented tongue to say that. So ladies, I'm turning red here. Okay. So when we're designing parts, we usually start with picking all of the things that are going to go into the enclosure, and then we design the enclosure, and every aspect of this piece of plastic is very carefully considered. Every feature, like the wall thickness, has to be the same. We try to optimize for cost and cycle time, which is how fast it takes to manufacture this part. There's a whole lot of thought that goes into making every single plastic piece. And then you have to design the mold that will make that plastic piece, and that takes a lot of work too, and expertise. And then you make your mold, which requires a lot more expertise to do. So, I'm going to blast through 9 different methods to manufacture plastics, and you will know you will have experienced something that came out of every one of these methods. So, in 16 minutes and 20 seconds, here we go. Injection molding. This is the most common one that you see. So injection molding means we take our plastic pellets and we put them in the hopper, and then the hopper goes into this screw, which heats up and compresses and makes the plastic into molten plastic. And then it squirts at tens of thousands of pounds of pressure into the mold, and then the mold cools and drops all the parts out. So, what you're looking at is 9 parts being made every few seconds, and then ejected. It's a pretty cool process. Also pretty inexpensive, although the mold can be very expensive. So, there are a couple of signs of pretty much all molding processes. One of them is called the parting line. So every mold has two parts that come together, and then you make your plastic thing inside of it, and then the mold separates, and where those two halves come together, you'll find the parting line. The other thing that you'll often see is something called flash. And this is sort of like a skin tag, but for plastics. So the idea here is the mold comes together, and then it comes apart, and then comes together and comes apart, and eventually it gets older and worn out, and you'll start to see flash, the little tiny bits of plastic that kind of squirt into that little error in the mold. Now with injection molding specifically, you'll see something called ejector pin marks. So when the molds come apart, they will stay in one side of the mold. And you have to be able to eject it out of that mold. So there's the ejector pin, which kind of pushes and it leaves a little mark. The other thing you'll often see is something called draft. So if the molds were at a 90-degree angle, they would be sliding against each other when they open and close, and it would wear out the mold, and that would be really bad. So every angle is slightly less than 90 degrees. And you can see that better here. Right. So there's also something called the gate. And the gate is the belly button of a plastic part. It is where all of the plastic gets squirted into the mold, and so it's always going to be a little bit ugly, but we try to make it not as ugly and put it in a place where it's not as visible. So I should quickly mention overmolding and insert molding. So with your toothbrush, you know how it's got that grippy part? Well, what happens is they'll make a part first using the white part in this picture, the white part. So that gets injection molded, and then they take that piece and they put it into a different mold and then squirt different plastic in, which goes into and around that other piece, and you get your overmolded part. Insert molding is where you would take a different material like a metal screw and put plastic around that. So like this part right here, there's a screw inside that's metal, and then plastic was insert molded onto that. Right. Extrusion. So extrusion is similar to injection molding, where we start with the hopper with the plastic pellets, and then we heat it up through the screw, except instead of opening and closing the mold, we're just going to push it through like Play-Doh. You remember that when you push the thing and it would squirt out? Yeah. So this is a continuous molding process. So it squirts out through a defined shape, and you can get as long as you want. Pretty cool. So this is how you get your cylinders and tubes and all of the pipes is through extrusion. All right, blow molding. So this process, those are not dildos. This process
Are you
takes,
sure?
guys. All right, it is funny. Okay, so all of your water bottles, those are blow molded. So the idea here is you can't get a mold to go inside of the hole and then expand out. That just wouldn't, the metal doesn't do that. So what you do is you start with something called a preform. And the preform is injection molded, but then you heat it up and put it into a different mold and then blow air into it, and it expands to fill out that mold. And here's a video. Neat. So we take the preforms and preheat them, and then you put them into the mold. This video is too slow. Okay. And then blow hot air into it, and it expands, and you got your water bottle. Neat. Now these will still have a parting line because you saw the mold opens and closes. So the parting line is probably, if you're looking for a parting line, look on a water bottle because they're always easy to see. Tip for anyone who wants to mansplain stuff.
Well, actually.
Right, and they're always hollow too. Alright, next up is roto molding. So roto molding is where you would start with just the pellets, and you put them into this large container, and you heat up the container, and you spin it. on 2 different axes. So as it spins, it's coating the whole inside of that mold. And then you cool it down, and you keep spinning it as you cool it so that the stuff doesn't settle. And then when it's done, you extract, you pull it out of the mold, and this is how you get enormous things. Yeah. So, roto molding is how you get really big hollow parts. Remember this, there's a quiz. Alright, next up, dip molding. So, dip molding is how you get your balloons. The idea is you take your molds and you dip them into this latex bath, and they come out coating the molds. And then, I don't have a video showing this, but what will happen is it will blow holes, or it'll blow through that mold until it inflates a little bit, and then some rollers will suck it off. It's really cool. Yeah, so that is dip molding. So some characteristics of dip molding are thin, stretchy, uniform. Remember this. This is for the quiz. Alright, so blown film extrusion. The idea here, remember the extrusion? Well, here you take the extrusion and you do a tiny, really thin circle, and then you blow hot air through it and kind of lift it up. And what's happening is it's making this really thin film, which then you fold in half after it's cooled, and you slice it with a razor blade at the end, and now you've got saran wrap. Neat! Yeah! So you can take this saran wrap, or you can make it slightly thicker and make plastic bags out of it, or whatever. Yeah. Okay, thermo forming. This is also called vacuum forming. And the idea here is you take a plastic sheet, maybe you use blow film to make the plastic sheet, and then you heat it up, and you drop it down onto a mold, and then suck all the... Okay, so... Right. Okay, so your candy trays. Those are thermoformed. This is a mold on the left, and the results on the right. And every one of those, or the mold itself, has a whole bunch of little holes drilled in it, in each of the corners, so that when you run the vacuum, it sucks all of the air out and pulls the plastic into each one of those corners. So all of your plastic food trays, the clamshells that you cut yourself on when you're trying to open up your new iPad or whatever, all that comes from thermoforming, or vacuum forming. Alright, next up is reaction injection molding. This one is fun, and you see it everywhere. It's so cool. Okay, so the idea here is, and this is a resin one, this is not a thermoplastic, this is a thermoset. So you take 2 different chemicals and you mix them together at a head and inject them into a mold. And then you close the mold and you wait, and the mold, depending on what chemicals you use, the 2 parts will either expand into a foam-like thing, like this, or they may just stay the same consistency but harden. So if you get in your car tonight, or bike, there's probably components on your bike that are reaction injection molded, but if you get in your car, your seats, the cushion part, that's reaction injection molded. So the form would be the form of your seat, and then the cushy part, those 2 parts, when they reacted, it expanded and then made the same shape as the seat. Also your dashboard, the steering wheel, and the styrofoam inside of the bumper. Also the bumper itself, like a lot of the panels on the car, if they're plastic, then they're done using reaction injection molding, because doing regular injection molding would require an enormous mold. So, reaction injection molding, pretty cool stuff. All right, next is 3D printing. It's cool, but you will almost never see it in use. Okay. And the reason for that is because it is so friggin' slow. Alright, here is a time lapse. Pretty cool. And what's happening is there's this filament that's being fed through an extruder. You remember what an extruder is? Which is just depositing little, like 1 layer at a time. as the head moves like the X and Y axis, and then every time it finishes printing a layer, the whole bed drops like 0.1 millimeters, and then it does the whole thing again. So what you just saw in 20 seconds actually takes like 4 or 5 hours. Yeah. So you don't really see 3D printing used in production stuff because it takes way too long. In production, you're looking for cycle times of only a few seconds. Like the injection molding video that we saw earlier, where it was making 9 parts at a time. That's because the cycle time is so much more important than the cost of the mold that it makes more sense to pay hundreds of thousands of dollars for an expensive mold that has a lot of cavities than it would be to do one cavity and repeat that cycle over and over and over again. So 3D printing is great if you only want to make a few of a part, but it's also not that accurate. So like one of the signs of 3D printing that you'll see a lot is the layers. So because it prints layer by layer, you'll see those layers in the print itself. And it takes a lot of work to get that out to make a prettier part. 3D printing is great for prototypes. So when I'm developing a product, I will frequently do a 3D print and iterate on those 3D prints until I'm happy with something. And then I'll send it off to an injection molding company where they'll spend a lot of money, like tens of thousands of dollars, to make a mold. And then they'll send me the parts like 3 months later. So 3D printing is great for immediate and low volumes, but when you want to get into the big volumes, then you use the bigger tools. And holy crap, I've been doing really well on time.
Yeah!
So, I wanted to talk about 2 local resources. There's the Baddeley and Sector 67. So both of these are maker spaces in Madison, and both of them have a lot of the some of the tools that I just talked about. Some of them are really expensive, like an injection molding machine is really expensive, and making a tool for it is very time consuming. We also don't have the roto molds that make the enormous tanks. That would be silly. But we do have lots of 3D printers. And Sector has a small injection molding machine. And if you wanted to do casting or reaction injection molding or some of the other ones that require less complicated tooling, then we'd be happy to show you how to do that. But yeah, Sector 67 and the Baddeley. You should definitely go and tour on Friday evenings. Both of them are open for tours, so you should go. All right, I promised earlier, a test. All right, so you're gonna tell me what production method was used to make each one of these things. Ready? Someone said Thermo Forming. That is correct. So it wouldn't be blow molding? No. Sorry, no.
Blow molding!
There we go. Yes, that is blow molding.
Rim job!
Yeah, there we go. Reaction injection molding. Yeah, it's actually one material that makes both the squishy inside part, but then it also self-skins, which is really cool. Yes, roto molding. Yeah. Isn't that awesome? So there's a lot of secondary operations that happen after it's been roto molded to cut the holes and make all of the other parts. But inside, like the base part of this is just, it's roto molded. Dip molding, yes. Yeah, that's dip molding.
It grows on a tree.
Yes,
Wait, which part?
3D print.
Yes, 3D printing. So 3D printing allows you to do some things that are impossible to do in traditional manufacturing techniques, which is kind of dangerous because people who are new to making products will design things that can be 3D printed but not injection molded or something else. So they have these great designs, but then that's as far as they can go. They can't make it. And this is one of those things that could never be manufactured in any other way than 3D printing. Yes, vacuum form or thermo form. That's correct. Yeah, injection molding. Okay, so Lego is amazing at injection molding. Well, they've been doing it for decades, but they have 90-degree angles, which means no draft. How awesome is that? They actually do it by having draft on the inside of the part. It's tricky, they get away with it, but they're making billions of parts.
2, 1.
Blown film. All right. Thank you all.
Give it up for Bob. That was wonderful, and you finished just on time. That was amazing. I've never seen that. We might have to get one of those for Nerd Night. So when Bob sent me an email saying he wanted to, and he sent that email to madison@nerdnight.com, he said he wanted to talk about plastics, and I was like, okay, sure, plastics. That's like different from what we normally hear at Nerd Night. I didn't know it would be so sexual. And related to that, about 5 people wanted to know how our dildos made.
Right, so... Okay, so first you would start with your positive mold, and this could be an actual penis, or it could be a 3D printed penis, or maybe you have an artistic person who could carve their own penis out of wood or something else. And then you would have your positive, and then you create a negative out of that. So you would maybe use silicone to create a mold.
I prefer silicone.
Yeah. So now you've got your negative, which is it has the cavity that's the shape of the dildo, and then you start pouring whatever materials you would want to. Typically it's silicone or RTV, and you would pour that into your negative and wait for it to harden, and
Harden. Yes, I couldn't help it. That's too good. Right. Wow, that is I didn't expect that. That's what I love about Nerd Night. So this just came in from Brendan Coyne. What is the most obscene thing you've ever seen molded? And I think referring to plastics, not.
Yeah, I think we just answered the question.
Okay, that's it right there. So one quick question that I had: Thermo Forming.
Yes.
Was that inspired by Han Solo getting frozen in carbonite? Or?
No.
No, okay, all right, just checking. Related to that, Drew Edge wanted to know, when were these methods developed? Other than 3D printing, which is pretty recent, how much time has passed between those? I know we saw Legos had injection molding, they've been doing that for a long time. Like, what are some of the timelines that we've had these around for?
Okay, so the first plastic was Bakelite, and it's...
Wow.
Yeah, it was in the early 1900s, I think. And it was by a guy whose name was like Baker or Bake or something like that. Yeah, it's after the guy's name, not because it's being baked. Weird. So I guess it would have to be after that. But like some of them are pretty recent. I honestly don't know.
That's all right. That's fine. That's fine too. That's fine too. I respect someone who says he doesn't know. That's cool. Yeah. Woo, yeah. Rounds of applause for admitting things we don't know. Unlike someone in the White House. 2017, we're gonna get a lot of those jokes.
Actually, all of these methods were invented 1.5 million years ago.
Oh, okay, nice, cool. Glad we got that timeline. So, our last, and we'll say final question, we'll say the winner for tonight. This is one I'm pretty curious about. John Fisher is asking, if plastic is in our cars, if the plastic in our cars is resin and thus non-recyclable, what do we do with them? Like, how do we manage plastics and sort of like the environmental impact of that? Any thoughts on that?
Well, so just because it isn't recyclable in the sense that you can't like cool it or heat it up and reuse it as the same plastic, it could be used for a filler for other kinds of things.
Thank you so much. Thank you. We're going to take another short 15-20 minute break, get some drinks, check out the outreach table in the back, and we'll talk to you in a minute.